If you are building voice or video agents, then learning to program with streams, handling streams of incoming data, and routing them is essential. Recently, Google introduced a GenAI processors library which provides very nice constructs to process streams directly using asynchronous programming. I'll go through a notebook here which illustrates some of the key features. This notebook is a very nice illustration of the streaming API provided by the GenAI processor library. So let's start. First install GenAI processor with pip, set the API key, the functions use it. There are three key concepts with very confusing names. Um, Processor part is the data that goes through the pipeline. And there are two operators, processor and part processor. Essentially, these two operators work over what are async iterables, lists of items that arrive asynchronously. So instead of having a list which is already in place, these items arrive asynchronously and are represented by the async iterable data structure. So processor takes in an async iterable and outputs an async iterable. So it processes each of those items and keeping its context in mind and outputs async iterable. Part processor works on the individual item. It doesn't have the whole view of the whole iterable. It only works on a single item and transform it to another item. Okay, so these are the concepts on which the whole streaming pipeline is based. So let's look at a simple processor, see it in working. The simple processor doesn't do much. It essentially replaces the text in each item. The dot is replaced by EOS string. Okay, so for async for part in content is the async iterable list that's coming in, and for each item in the list, if it is a text, then replace the dot in the text by EOS. Okay, and for that it uses the processor part API. Okay, so this is a simple text processor, and this one is a processor that encapsulates it. Okay, now applying that processor, let's see. Here we have slightly modified the original notebook. Let's run it. Okay, so we start with input hello dot world dot there are two dots here, and it goes through a simple text processor, input stream, and print part dot text. And instead of hello dot, we get hello US world. There are two dots. They're replaced by two US. Okay, so what's happening here is that we take the static list, we convert into an async iterable by calling the stream content function. That comes into a stream, and then the text processor acts on the stream, and for each part outputs the text. So it has transformed it. Okay, so we converted a static list to a async iterable. We can convert it back by having this apply sync. We can use a function that works synchronously as opposed to asynchronously, and we get the same output. Okay, so the next item is how to chain. If we have multiple processors, then how do we build a pipeline that consists of multiple processes? So the key is this plus operator. This is the sequential composition operator. Okay, so is another text processor. What it does, it just it converts it to a lowercase. Okay, now if we do simple text plus another text, it's a very convenient way of putting those two in sequence. And now if I have a input string which first dot and second dot, can you guess the output? It's first EOS, second EOS, and then everything is in lowercase. So the first simple text converts it, removes the dot, converts it to EOS, and then second processor converts into lowercase. Right, so this is fantastic. You can write multiple This allows you to build modular programs over streams where you put multiple processes in sequence, and and uh, each of them will do their own job, and the output will be a composition of all of those. I talked about metadata earlier as each data item, which is the part here, which is accompanied by metadata. And this is an example that shows, so simple text processor with status. What happens here is after replacing a dot with US, also adds a status field, simple process done on part.text. Okay, and the rest of the program is same. It goes through simple and another text processor, same input. Let's see what the output is. So the second part, so you get a sequence of items in the list, the output list. The, the the first and third items are the original content, and in between are these status frames which you can distinguish by the substream name. So this metadata field substream name helps you add additional field, additional tracker, or additional events to the pipeline. And that's very useful in building more complex strings or tracking specific events. So next is a parallel. We saw sequential composition. Now parallel composition and if then else or switch statements. So there's a parallel concat statement which will run the two processes in parallel, and the output, you can see the it's lowercase done by another text processor, US added by the second simple processor text, and both are sequentialized in the pipeline. Switch case or if then else is the interesting. So this shows switch case based on the metadata, which is the substream name. So A1 belongs to the substream A, B1 B, B2 B, A2 A. Okay, and we will switch on the substream name because is the function that gives. So if it is A, then processed by another text. This will be lowercase. B, it will be the dots will be replaced by the simple text. So let me just add a dot here. Okay, so let's see what the output is. This is A1, A2 are processed by the lowercase processor, and simple text replaces the dot. Right, so this is a very nice example of how to do an if then else based on the metadata of streams, and that's it's useful in many places. And there's a default statement, so this is really mirrors the standard imperative if then else. The idea is that if this case goes through, then the data just goes through that pipeline. Otherwise, it goes through this pipeline, or otherwise just passes through. So it's important to keep that semantics in mind. So then we come to the processors as GenAI models. So till now, we have been just playing with the structure of the processors as generic stream transformers, transformers of the components of the stream. What if we decide to make some of the processors as GenAI models? We'll cover that in the next video.